You're listening to Worth Electronics What's Up Radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Worth Electronic technical specialists. We're going to shine a light on interesting topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast. Much like anything else, fuel prices are on the rise, and one of the major topics that has come out of electronic conferences lately is energy harvesting. And it looks like this futuristic idea is even closer than we think. In today's podcast, we'll explore the world of energy harvesting and also discuss ways that you can not only harvest the energy, but use it to power your electronics autonomously. Worth Electronics' Laurent Focal is the master of all things energy harvesting, and in a popular webinar, he brings an introduction to energy harvesting and what type of ambient energies are available. Laurent will also discuss challenges in converting and storing these energies into usable energy, give examples of real-life uses, and then finish off by examining the new low-power converter ICs that can be powered from multiple harvesters at the same time. Enjoy this presentation of energy harvesting development steps with Laurent Focal.
Hello everybody, my name is Laurent Focal. I'm working with Worth over 20 years. I'm field application engineer and was before also a developer for electronic devices. I would say in the last 6 years I'm researching in this field of energy harvesting devices. And because of that, I will try to share with you some information, some ideas. When you do energy harvesting devices, your motivation is mostly you try to do an autonomous device, a sensor node, or just IoT, something which is working without maintenance. First of all, if you use a battery, you can extend the battery lifetime if you use energy harvesting additional. And that can be very useful, especially when you have a place where you have to put this device, which is very, very difficult to be accessible. So I think the energy harvesting by today, it's quite important in our developments. If you're thinking for energy harvesting, first of all, the first idea, it is energy for free. Well, in yes and no. It's energy for free if you have non-electrical energy form around your device, which you can catch without any importance that you will generate another leak of energy source for the device to generate this kind of energy. Normally, you find some different light. This is normal ambient light, which you can harvest. You can harvest temperature differences with Thermoelectric Generator. You can harvest movement by vibration. You can do many things with energy harvesting, just even a chemical harvesting. It could be possible if you have a high pH value of your wastewater, something like that. In the mechanical age, we had this kind of buoy for the ship when it's approaching the port, that when it's foggy and the ship is coming to the port, he makes some waves on the water, and that generate that this bell start to make some noise, and the people can hear that and then say, okay, we are too close to the walls or we are too close to the ground, and then we have to take care that this sound is not so loud because we're approaching too close to the ground and it will be a problem. In today's age, by digital age, I will say, more like 20 years already existing this kind of electronic buoys which are harvesting by solar cell the light, and also harvesting the movement of the waves and give you much precise GPS ground position, and not just a bell ringing a bell. And you can do in the same water street, more like one ship in the same time. So this kind of device can be done only if you are working on each stacks of these different modules in a very high precision and very efficient, because the RF module must be very efficient, the management, the power storage must be very efficient, and also this kind of software must be intelligent made, that when it's no need to transmit, to just take the energy and accumulate it and store it somehow, and only just when it's the need to be transmitted. First step in energy harvesting development is to know not only just the maximum current. You need the peak current as well, but you need the whole, I would say, the whole demand of in time, because not always you need this maximum current at your load. You have in a time when is no calculation need or no sensing need, you can put the microprocessor in deep sleep mode, and you can wake up on the event, on the threshold, and then make your calculation and again put to sleep, and you can keep in deep sleep mode at very, very low leakage of the current, which is sometimes even less than the leakage of the internal resistance of the battery. This is very important when you develop energy harvesting devices. I saw that many developers just take in consideration the maximum current, and they assume they need always this maximum current output for the DC-DC converter, which is not real. The second step, you have to consider which kind of different source capability you have around the device. You can harvest in the same time solar and thermoelectric, or you can harvest solar and movement, or movement and thermoelectric. It depends on the environment. Better is to have a multi-source combination, like to just concentrate on one source. As well, it's very important to make a data logging over a certain time, that you have the availability and stability of this non-electrical energy source to be safe, that okay, if I make a device with solar cell and I will sell it to the polar area of the earth, it may happen that 6 months there are no sun at all, and moon charging by solar cell doesn't work today. The third step is to find now the right harvester. If you know exactly your energy demand and you know which kind of energy source you will be able to harvest, you need the right transducer, the right harvester. Additional to the harvester, you will need to store the energy somewhere where your device is not operating and not working, or not need to be any calculation or transmission. You can choose a capacity bank, you can use supercaps, you can use this ultra caps, which is a combination of supercap and lithium polymer. And lithium-ion rechargeable battery is the biggest possibility, the highest energy density, which you can do that. After you're deciding which kind of source you use, you can see that there are big difference between this harvesting of the non-electrical form. You can harvest like RF. RF harvesting is mostly the not so effective, because you have only just 0.1 microwatt per centimeter square. And even if you're living close to a mobile phone base station and you build a nice Yagi big antenna with a extremely good wind, and focus to the mobile base station, and you put the LED on the end, it works. But guys, this is illegal. It's not so good. Don't do that. Especially in Germany, we have laws which not allow to you to do that, because you suck away from the network provider a lot of energy. You have to put 100 times more energy in his base station just to make your few milliwatts LED to light on. So this is not a good idea, but it's possible. It works. I saw some device which are trying to harvest Wi-Fi signals. Yeah, it is working if you have very close access points, but the problem is, where the harvester works, you will have a problem to connect with your mobile phone or with your laptop to the base station, to the access point. So this is not the cleverest. By vibration, you can harvest up to 1 milliwatt per centimeter square. It's quite very good. You have a quite good voltage. With the thermal harvesting, with thermoelectric, you can achieve 10 milliwatt per centimeter square. Thermoelectric is this kind of not Peltier. It is called the Seebeck effect. It looks very similar to this Peltier element, but by the thermoelectric generator, you need at least 5 Kelvin temperature difference. So if you have more like 5 degrees Celsius temperature difference between two rooms, you can think about thermoelectric generation. I know one guy who's making by 60 Kelvin temperature difference, so 60-degree temperature difference, he can achieve even 1 watt per centimeter square. The problem by thermoelectric generator is that the price is not so good right now. It's quite expensive passive component. Photovoltaic, of course, I guess everybody had already a small desk calculator with solar cells, which never change batteries or something like that. And photovoltaic solar cells for indoor, outdoor, or even hybrid one. There are a lot of different standards already on the market. Interesting is that harvester getting more and more capable to produce electricity, to transfer this non-electrical form into electrical form, and computer chips are getting less power consumption. So I don't talk about mobile phone right now, okay? But you can find ARM Cortex processor which is operating already by 150 nanoamp. So this is really crazy what today is possible. And just try to remember 10 years ago, if somebody tell you that it will be able to make a 50 megahertz processor with 150 nanoamp, how to measure that? Because of that, we did develop together with former linear technology, now is analog device, the new name. We did develop with these guys a demo kit where you have it is a chip inside with ARM Cortex M3 core, and on the chip directly on chip is also a RF module built in directly in the processor, and you can go on one leg directly to antenna, and you have a LED, not LED, A-ink, sorry, A-ink display here, where we did choose a A-ink display to achieve only low consumption you need for the pixel only current when you want to modify to rewrite it. And we decide with this device to make a smart mesh network because it's working in a proprietary protocol by 2.4 gigahertz, and it's a mesh network. And you have also a USB dongle where you can try out this device. And it's everything built inside. You have a power board where you can harvest simultaneously solar cell in series, solar cell in parallel. You can add a thermoelectric, you can add piezo additional or inductive harvester. You have also the possibility to switch on a backup battery, a lithium cell. You have the possibility to put additional secondary battery, like a rechargeable lithium-ion battery. And all this power management is making the power board by the DC-DC converter. And after supplying this 3.3 volt, maximum 50 milliamp output, it can power on this smart board, which make with different sensor. You can add here to this connectors. You have also with the kit a kind of shield board where you can put your own sensors and devices. So this is something which you can make your first steps in energy harvesting development without to make a special board and so on. You can even measure the current consumption. Behind this board is also two column counter, because to measure 150 nanoamp is not trivial. It's very difficult, and you need to power on this column counter, which is sucking much more energy like the power board can do it. So for this reason, you have here a USB port. If you download the quick eval from quick eval exe, the file from analog device, you can connect that, and you have a GUI where you can see the power consumption of the chip from different function. You have the possibility to put motion sensor, temperature sensor is already, and humidity sensor is already on it, and you can put different sensor additional. This is the power board where you can see there are different power DC-DC converter. Some of those are working only with solar, other one only with just with a TEG, and some of those work with piezo solar and have lithium and supercap balancer as well. All these jumper and switch you can add to each one, each DC-DC converter, and you can try to see what is the efficiency and how good you can convert this electricity in non-electric in electric form. This is very easy. Already it's delivered in operation function, so you don't need to redesign anything. Just if you want to make your own design, you can ask for the Gerber files and you can make copy and paste and works. For the smart board, I can tell you it's an ARM Cortex M3 core inside with the smart mesh technology. You don't have to carry on for this network IP and connection. So he's very clever, made that. I think right now on the world, it's an analog device with this smart mesh, which has this low power consumption technology. And the next one, who's quite very close and very efficient as well, is wire pass protocol, which is also by 2.4 gigahertz protocol working. Uh, yeah, this is something which you can get like a design kit by using like the LTC3330 DC-DC converter with a primary cell battery. You can see here, this is the output voltage from the DC-DC converter. And as soon you supply from the solar cell, the harvester is running on, automatically the battery will be totally disconnected and you have only just the leakage from the internal resistance of the battery. This is like the LTC33 working with a piezo and the solar combination, the primary cell battery. It can be possible also to put optional a super cap because it has a balancer for a 2.7 volt, 10 millifarad super caps as well, and it's quite really easy design. The first harvester that you ever use, if you are riding a bicycle, it was your dynamo. When you click on this quite heavy old dynamo to your bicycle, you did already done have energy harvesting. Maybe you was not aware about that, but that was the first harvester maybe which you did use. Okay, efficiency was less than 10%, and you was already feeling that your bike is not so fast and you have to push this additional power. But it was on the beginning the first harvester. Today, I say by the bicycle, maybe it's a different one. You have this modern bicycle harvester generator in the axe on the wheel, and this is not so bad. And with the LED light, you don't need to produce such big friction, and you know, I'm not so heavy to ride a bike. Companies like Enocean or PMDM, they make also some nice devices. This from PMDM, they are just for demonstration. It's actually a shaker, and you shake it and generate electricity with a magnet between two coils. Enocean made this switch, which when you push on the switch, you make a RF remote control switch where you don't need battery for maintenance, you don't need to wire it, and you just can glue it to the wall if you make modification like in your house. This is from you can buy it from stock. This is very popular product already on the market, more like 10 years already existing. And this simple click on your button, this 30 microcoulomb, it's enough. This energy is enough to generate 30 microcoulomb per click, and this can be enough to transmit 3 times the signal light on. So you never need maintenance. You don't need to change battery. You don't need wires to that. It's very nice, especially when you have a glass wall. You know, glass wall and wires doesn't look so nice, and you just click it at, and that works and perfect. You can get this kit also from these guys. They have also solar harvester. They have also these different modules as well. You just have to try out if you want to design something by the Enocean kit. Right now, they also have a gateway between Zigbee to Enocean and also to Bluetooth. Another company like ZF Sherry, they developed these industrial harvester switchers. It's quite in the shape of the typical industrial size. Also, this micro switch is a harvester which are harvesting the same way the motion of this small spring with a magnet. And you can just plug and play and operate already. You can make automation wireless without maintenance, without battery. The receiver, of course, you need always energy source. You have to be connected to grid, but it's quite very interesting how easy it is today to do something by energy harvesting devices. companies like Ferro Solution and Perpetuum from UK, they developed this kind of harvester for the train wheels. In UK, they are running several trains, special high-speed trains, with this wheel monitoring, this monitoring the vibration by the train, and soon the tire train will have a problem or crack or something. It changes his fingerprint of the vibration and automatically start to make a beacon to the gateway that there are something wrong. And this is completely energy harvesting, completely maintenance-less. You don't need anything, just screw it to the wheel and that's it. It works until the train will be destroyed. Yeah, this is one of the application from these guys. If you want to do something by ceramic, I was in a ceramic by Piezo. PI Ceramic is one of the supplier who can do these different shapes of this piezo standard harvester. You just have to glue it like me. I put it on a carbon piece of carbon, and if you move this carbon, it start to generate electricity. And with our demo kit, you can operate the processor like that. Using a thermoelectric generator by the TEGs, it's the problem that they start at 5 degrees Celsius temperature difference, but they start with very, very low voltage. They start by 30 millivolt to maximum 1 volt, and the problem is by 30 millivolt, this is not enough. 0.7 volt is needed for this NP junction by the transistor, so 30 millivolt is too weak to him, so you need to boost up. And now Virtual Electronic made a good product, this kind of small transformer. Actually, we said this is a inductor special for energy harvesting, and actually it's a 1 to 100 small transformer. Soon the 30 millivolts come here, it is amplified by 100, goes to the IC, and the IC start to operate. But wait, DC, this is a thermoelectric generator. It's make DC current. And how to operate a transformer with a DC current? This is almost impossible. You need always a flux change. You will always need a change that is happening, that a transformer works. When you put here this voltage and start to rise the voltage, this is okay. You have a flux, no problem. And the IC is that clever. As soon you apply this rising voltage to him, the first what he will start to do before he start to put output voltage or stabilize on anything, he start to swing this pin, this switch node. It is coupled to the transformer on primary side. And then it start to switch on and switch off, and starting switch on, switch off, it generate by the DC voltage a flux in this coil, and then you have the 1 to 100 transformation. Soon the self powering it's reached. He has a output for a capacitor after his charge. This is his backup where he's getting the power out, and then he start to deliver the output voltage. So first feed yourself and then give to somebody else, and that's make the chip by himself. And it's very clever, and it's a very nice design. It's quite very efficient as well, up to 97% efficiency, of course, by low voltage. And we talk about voltage input to voltage output, not thermal to efficiency to electricity. But this is a cool stuff, and the coil is quite simple, maybe not that simple. If you look here, this is the 1 to 50. You can see here the wire thickness 1 to 50, and this is 1 to 100. By 1 to 100, we use the thickness of this primary wire thinner like the human hair. This is the lowest diameter of the wire which a winding machine can handle it. So it is extremely thin, almost I would say invisible. If you have in front of you and you have a piece of wire, it's almost invisible. And the secondary thickness of the wire is not that thick because we want to drive a lot of current through him. No, it is because we want to keep the DC resistance very low. So this is the EHPI transformer standard. If you do anything by using a TEG, just ask for samples. We have 1 to 20, 50, or 1 to 100 transformation, and we have few of those, also some different values if you want to have that. But this is standard from stock. ask our sales guy for free samples. They will be happy to source to you these free samples for your testing. Different application like tracking, monitoring of this container. One company make tracker which is built to the container. When the container is on the ship have a ground vibration from the diesel engine, and they can harvest this movement and can track the container if it's still on the ship. They transmit to the gateway. A gateway have a satellite communication, and then you can track the container if it's still on the ship or is somewhere on the ocean already lost. The railways are using more like 20 years already harvesting the sensing the railways motion. So I can tell you from German, the railways over 20 years already using harvesting for sensors. In building automation, climatic control can be used very often, this kind of energy harvesting in plant automation, remote monitoring of pipelines, it's also energy harvesting. And the last generation of the power harvesting of tire pressuring measuring system, the clever guys are using not anymore batteries, they're using the motion and the temperature from the tires and the wheels, and they can power on. The first generation was made with batteries, so after 50,000 kilometers you need new tire sensors. The second generation was with battery, you can change the battery, and the third generation it is with cleverness, with a kind of energy harvesting, life extension of the battery. Still is the battery, but life extension. Another application which I found, it's from the company ABB. They make this kind of temperature sensors and also wireless mesh network. They're using a thermoelectric generator for measuring the temperature and generating at the same time the electricity for the RF sensor. And yeah, this is something already industrial standard works. You can imagine if you have a plant where you have to place these different sensors in a oil refinery or something, and you don't want to climb every 6 months and change the batteries there. So this is quite very clever. Company like Fraunhofer Institute, they made also a very nice chip on system on chip where they put a solar cell above the processor, in everything in one package, and in this processor they have DC-DC converter, they have the accelerator sensor, they have the RF module, they have the solar cell on the chip, and you can put between these glasses in the window in the vacuum area, and you can monitor if the window is open or closed, and it works with daylights or indoor lights both. I'm very sad because this is not a product which is getting already on the market. I will be so happy to have that kind of windows myself, to not need to make any additional sensor to glue it, to drill it or something like that. We make also a questionnaire to the customer, and we ask more like 2,000 different customers who are doing something with energy harvesting, and the the smallest energy which was harvested, it was something like 50 microwatt, and the maximum power which I get information from the customer in the feedback, it was 5 watt using solar cells. The 5 watt was using for GSM GPS module, which is using for some meteorological station or something like that. But there are many different applications already on the market, like also harvesting the magnetic field by high voltage cables to have a status about the high voltage cable if still operate properly or not, and water purification plant harvesting the chemical from the wastewater, and this is the battery. In fact, very interesting application which is already running on the market. The biggest and nicest invention what I saw was for 2 years ago on the CES in Vegas. It was made from the company L'Oreal. It is a UV data logger. The small devices, you can stick it to your fingernail. This is the correct picture. It's original from L'Oreal. And this stick it stuff in your fingernail, it's measuring during the day the UV light which you have been exposed, and on the evening you can take your mobile phone, and with the NFC, because you can see this also NFC antenna, you can read out the data and recommend to you which kind of sun blocker you have to use next day if you want to have a protection to your skin, or you don't want to get burned, or maybe your skin is sensible to UV light. And clever guys, L'Oreal, who make cosmetics, make designs of electronics, never imagined that. They use a LED, a UV LED for harvesting. That's the source. Very clever guys, very, very clever guys. So this is one of the interesting what I found in the market already. And another nice project which is making Professor Rogers on the University of Chicago with his team, he did develop a special mesh, a kind of piezo mesh, which is directly woven to the heart. And with this heart moving, when the heart is beating, is harvesting this movement. And with this movement, he can apply this energy to a pacemaker. So he did develop with his team a pacemaker, which is working like almost perpetuum mobile, of course, because you have to feed the body to beat the heart. But you can imagine what this mean for the people in the future who has a pacemaker, that they will not need to change the battery after 6, 7, maximum 8 years. They need a surgery only because of the battery. The pacemaker himself, they say they guarantee more like 20 years operating. The problem is the battery. And with this development, I cannot show you some picture because they made already tests on living animals. They can do pacemaker only just using the harvesting the energy from the mechanical heart beating, and this is so weak that even the heart doesn't have been damaged or something like that. Also, the same team from Professor Roger make there this kind of stickers on the body. This is the first prototype you can see here with the multi-layer chip antenna and the storage inductor and some discrete components. And they develop right now this kind of sticker where you can have with solar cells and ECG sensors and blood temperature, blood sugar, temperature of body, humidity of your skin. Crazy. It's really crazy. You can just stick it to your skin, and you can go even to the shower. It's no problem. It's waterproof, and it works also harvesting on your skin, and you don't need to wear almost a smartwatch, or you don't need this plug for the finger for blood oxygenation. By the way, the last generation of these smartphones already have also built in, but this is not a sticker, it's a smartphone. So this is more intelligent. I think in the near future we will be able to buy this kind of stickers. And the most funniest thing what I ever found, it's a Brazilian guy. He get the Red Dot Award for an energy harvesting device, which is harvesting during the sleep, the snoring. And during your snoring, you can charge your mobile phone. It's very interesting. And by the today pandemic, using that kind of mask, if he will be clever enough and start mass production, because he doesn't have mass production, today he could make a lot of money by using this kind of mask. And you can see even you can use that on outdoor using with a HEPA filter. Additional, you can charge your mobile phone and you can snore without making noise for any other body. And yeah, it's very funny. It's interesting product. Yes, if you want to develop, we have these two kits. You can ask that for our salespeople, or just access from our website and place your order if you want to have that. One is this to-go kit. The to-go kit is developed together with Silicon Labs with a Giant Gecko ARM Cortex M3 core. It has also doesn't has RF module inside, but you can do very simple designs with this Giant Gecko. And the Glenergy board, this is developed with analog device together. This is with RF module, and you have also a dongle that you can communicate with the kit, and have also this shield box where you can connect your own sensors or anything else.
This podcast was taken from a popular updated Worth Electronic webinar. To view the materials and replay the webinar on demand, visit us online at www.we-online.com/webinars or click the link attached in this podcast. You can learn more about our energy harvesting applications by visiting Worth Electronic online. Look for this episode in our profile or click the link available below. You're listening to Worth Electronics What's Up Radio podcast, and each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Worth Electronic technical specialists. We're going to shine a light on interesting topics such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast.